Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I run online seminars for exams PFM, IFM, and LTAM at Illinois State University. You can find information about it at smarturl.it/btdt-online. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P. A large pool of adults earning their first driver's license includes 50% low-risk drivers, 30% moderate-risk drivers, and 20% high-risk drivers. Because these drivers have no prior driving record, an insurance company considers each driver to be randomly selected from the pool. This month, the insurance company writes 4 new policies for adults earning their first driver's license. What is the probability that these 4 will contain at least 2 more high-risk drivers than low-risk drivers? And here's the solution. So let us write X for the number of low-risk drivers insured among the 4, Y for the number of moderate-risk drivers insured among the 4, and Z for the number of high-risk drivers insured among the 4. And let us write F sub xyz of xyz for the joint probability function of x, y, and z. These are discrete random variables, so it's a probability function. The joint distribution of x, y, and z is trinomial, and what we're looking for is the probability that z is greater than or equal to x plus 2, and that happens when we have 0, 0, and 4, so 0 low risk, 0 moderate risk, and 4 high risk, or 1 low risk, 0 moderate risk, and 3 high risk, or 0 low risk, 1 moderate risk, and 3 high risk, or 0 low risk, 2 moderate risk, and 2 high risk. These are all possibilities that encompass the event that we want. And then we just write out the trinomial formula for all of these cases. So the number of ways to pick for all high-risk drivers out of 4. So there are 4 people there, and how many ways do we have to arrange the various risk drivers among the 4? That's 4 factorial divided by 0 factorial, 0 factorial, times 0 factorial times 4 factorial, times 0.20 to the 4th. And this is more or less a direct generalization of the binomial distribution that you should know, but you should know the trinomial distribution for the test. That's why this problem is here. Then for 103, the probability is 4 factorial divided by 1 factorial times 0 factorial times 3 factorial, and that's multiplied by 0.50 for that 1 low-risk driver, times 0.20 cubed for the 3 high-risk drivers. And then 4 factorial divided by 0 factorial times 1 factorial times 3 factorial times 0.30 for that 1 a moderate risk driver times 0.30 cubed for the 3 high-risk drivers, plus 4 factorial divided by 0 factorial times 2 factorial times 2 factorial times 0.30 squared for the 2 moderate risk drivers times 0.20 squared for 2 high-risk drivers. You can also write 0.50 to the power 0 here, but it's not necessary because that's 1. And then we calculate all of these numbers and add them up, and the answer is 0.0488, which is answer D. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.